Regression analysis is mainly used to measure the relationship between two variables, x and y. So regression can be used to measure a positive relationship or a negative relationship depending on the direction. So we have the variable called R, which is the coefficient of what? Variation, the coefficient of correlation. So it is given by SSXY divided by SSXX times XXYY, SSYY. So in this case, that is called the coefficient of correlation. It gives you the direction, whether it's a positive or it's a negative relationship. So this is a negative relationship because it's downsloping. This is a positive relationship because it is upsloping. So when you square this answer, so I said R stands for coefficient of what? Correlation. When you square that answer, it is called coefficient of what? Termination. Coefficient of termination measures the influence that X has on Y. It measures the strength of the relationship. So if you have R squared is 0.9, it means 90% of Y is because of X. If your R squared is 0.1, means 10% of Y is because of X. It is used to measure causality. Most of you have been taking in your research. I have a huge class of researchers, students, so I'll ask for this knowledge when I'll be assisting you in your research. So you need to start thinking about topics right now, because QM is mainly meant for you to apply in your research works. So we also have a regression equation, which is given by Y, so the A plus BX, where X is Y is a dependent variable and X is the independent variable. So in this case, B is a slope and X is a what? Independent variable. Here's the input. So to find the value of B, which is a slope, we simply find a variation in XY over the variation in XX. In the formula for the slope, A is the intercept. An intercept is simply cutting point. So this is given by summation of X, summation of Y over N minus B, summation of X over N. All right, so this is a prediction equation, which is used to predict what Y can be once we input X. So what are these X's and YY's? These are simply variations. So the variation in X has X's throughout. So this is summation of X squared minus summation of X to the power 2 over N. So you need to memorize about 98 formulas to be very ready for the exam. Otherwise, you use the what? The memorizing those. You'll be given formulas also. You need to know which one's appropriate when. So the difference is YY as Y's throughout, X's as X's throughout, XY as X's and Y's on each side. So summation of XY minus summation of X times Y. So in this case, after finding these figures, you're able to find what your figures are. So for instance, just using arbitrary figures, if your XX is, for instance, 10, your YY is, for instance, 6, and your XY is, for instance, 7. From the formulas I've given you, the slope, who remembers the formula for the slope? Slope is what? XY divided by XX. So what is our slope? 7 over what? 10, which is 0.7. Okay. How about our R? R stands for coefficient of what? Correlation. What's the formula? Xy over what? Square root of xx times yy. So here we're going to have 7 over square root of 10 times what? 6. So we're going to have 0.903. That is how we find our coefficient of correlation. When you square this, it is called your R squared, which is 0.816. So just using these very formulas, you get about 10 marks. I don't need to explain much. All right? I don't need to explain much. You need to master these formulas.
So the challenge that comes in, the English that is used. When he uses that funny English, now you're trying to figure out what is the SSX, what is SSXY. That's where the challenge comes in.
All right. So it will just ask you to find the correlation of coefficient. For instance, you're given values of x and y. 1, 2, 3, 4, and 5. And here given y is 1, 1, 2, 2, and 4. Just for you to, for simplicity's sake, xy, x squared, and y squared. When you multiply them here, you have 1, 2, 6, 8, and 20. Here, when you square each of them, it's 1, 4, 9, 16, and what? 25. And here, yy, we have 1, 1. We're just squaring individually here. 4, 4, and what?
4,
16.
and 16.
Then when you total up here, the summation of x, this is 15, 10, and here we have what? 37, 55, 26. So this is called summation of x. This is called summation of y. This is called summation of what?
Summation of xy.
And this
xy.
is
Summation of x squared.
And this is summation of what?
Y squared.
All right, so how do we find sum of xx? He said this one is pregnant with what? X is throughout. So x,
Okay.
x. But except that one is a small x and the other one is a big X. So summation of x squared is 55 minus what? Minus 15 squared over what? N. N is the number of observations, 1, 2, 3, 4, 5. So N is 5 for each of them. So over 5. So when you compute that, you get 10. So how do you find summation of y? So y is throughout, right?
With y. So sum of y squared minus sum of y squared over n.
Correct. So here we're going to have what? 26 minus what?
6 minus 10 over 5.
Yes. So here you're going to get a 6.
Okay.
How about if you do?
Okay. Pregnant.
So this is what? Summation of what? xy minus summation of what? X.
Okay, x alone.
Summation
Okay,
of y
squared.
alone by n.
Okay, alone.
All right.
Okay.
So here it is what? 37 minus what? 15 times what? 10 over what? 5.
Over 5.
So we get 7. All right. So we found xx, yy, and xy. If you're able to find this, where is the problem? Then we'll go back.
So maybe I think like Dingy said, Collins.
Yes, please.
So when you are presented with a question, is it easier to identify X or Y, or maybe there's a jargon that you need to trigger out before determining which one is X?
The question coming is this one. So if you fail to remember that, just memorize the answer, yeah? So,
okay.
Given this question here, index.
Okay, so which one is X, which one is Y there?
Yes, that's where a good question is. So here he hasn't manipulated. So you should know that X is called the independent variable and Y is called the result. So we have an index which has industrial production, and the number of registered employees. So number of employees are the input. The index of production is the output. Okay?
So the one that depends on the other is the Y.
The Y that depends on the other is the Y. The X is the independent variable. Okay?
So in short, X is the boss.
Yes. Okay?
If you want to remember it in
Yeah,
that way.
X is the boss, exactly. Yeah. So index of, so sometimes.
But looking at the formula, since, Colin, sorry, looking at the formula, since X and Y are multiplying each other, even if you have to interchange them, you have to arrive at the same answer, correct?
Yes. Yes, especially for correlation.
But you lose marks, of course, for not identifying.
Well, in this, I love correlation because whether X or Y has been interpreted, they have been interchanged, correlation is always the same. So here you're safe.
Okay.
Thanks so much.
Okay.
Yeah, but akangena kaisa exactly. Please just memorize it. Look, so X is this one and the Y is there. So XY, you're multiplying this guy and that guy to get that. Then X squared, you're squaring this. What I was doing there, get the totals. Are we clear on the totals?
Yes.
No, on this one, I think let's just go through.
We're going through. I'm just not going to calculate them manually because everything has been calculated. So I'm saying X, 100, 102, 104. These are the figures here, the values of X as they are appearing here. Then you total them up. You're going to get 2716. Then you can, him or systematic maybe, he squared them individually. And you got these figures. Are we together on where this is coming from? Leah, are we together?
Yes.
Then we go to the Y's, 15, 12, up to the end, 26, total them. That's a figure, they're 120. And you square them individually. That's a total 1984. Are we together?
Yes.
Then now go X, Y, you multiply them. The total is here. Fortunately enough, in the exam, he gives you the totals in advance because he doesn't want you to be so disturbed. It's very good. So remember, XY is pregnant with X and Y. YY is Y is throughout. XX is X is throughout. We've seen these ones, right? Are we together?
Yeah, at this point.
So, and ARA is XY, XX times YY. Chiluba, is Chiluba there?
Yes, I'm following.
Yeah, following. Okay, great. So once these inputs are there, okay, it's an issue of just entering them. So XY, you put them there, you get what? Negative 57.4. XX, when you input them correctly, you get what? 3136. And YY, when you input them correctly, we get 184. So the issue is now to fuse them in the calculator. So XY over XX times YY, getting these figures here, we're going to now put them negative 54, 57.4, then you multiply these two. So our error is 0.239. This is 10 marks. Okay? He didn't even ask, were you asked to interpret? You're asked, what is the coefficient of correlation? It is this one, negative 0.39. What is the interpretation? X and Y are inversely related or negatively related. So I told you the job of R is to measure the direction. If you get a negative, say they're negatively related. If you get a positive, they're positively related. Sharp. Are we together? Leah, Kaisa, remember the answer is what? Negative 0.39.
Negative 0.239.
Good. Okay. So lastly, the easier part is on the linear prediction. I'll go back to my question because it's your prototype. It will lead you to that. I don't need to explain so much. It's nice to teach master students because they understand very quickly. So having found R and R squared now, the other part that we need to know is the regression equation. Y is equal to what? A plus bx. So you cannot find at your level A before finding B. So B is equal to what? Sum of square xy over sum of square xx. Remember this one, right? So here xy was 7, our xx was 10. So here we found 0.7. So we found one part of the answer. So y is equal to what? Dash plus 0.7x. So now we need to find a. Formula for a is summation of y over n minus b summation of x over n. So summation of y was 10, our n was 5. Our b is what we just got in here. So if your b is wrong, it will affect your a. Then our x was 15 over what? 5. So this, when you compute it, you're going to get 2 minus 0.7 times what? 3. So this final answer will give us negative 0.1. So here you put negative 0.1. You get your 2 marks for just the equation. Then the second part, they'll ask you, obviously, they'll find a figure. Just to confuse you, suppose x is what? 10. Input it to find the boss, like my colleague just mentioned. So where there's x, you put what? 10. So when you put a 10 there where there's x, you're predicting the y. So when you put it there, you're going to get y as 6.9. That's all. You get your 3 marks here. So this one has few marks, but worth it. Every mark counts. So you get your 5 marks total. So let's go to the question which is coming now. I don't want to waste much of your time. So when you have this question here, all right, you are being asked to find the regression equation and suggest to him the weekly rate at which his sales are rising. So what determines is also the gradient here. So what is the implication of this gradient? What is the implication of this coefficient? I can say it in terms of sales and advertising. If a sales figure is 10 plus 2x, so it means this 10 is a intercept. Those of you who are doing managerial economics, I don't know. I don't want to speak much, but I explained this. It's an intercept. So the 10 is where it's starting. It means an autonomous point where even if there's no advertising, we can put a there, we can still make a sale of 10 kwacha. Then this 2 is a gradient. It's a rate at which your sales are raising. So similarly here, this gradient should be actualized to the question, the way the question is coming. So here we've been asked to say, we're dealing with what? The owner of a shop. His sales are rising significantly every week. The trend also is recorded in each week. It's being analyzed. So here, week 1, week 2, week 3, then the sales are so much. So come up with the linear equation. So like I've said, the weeks are x, which are independent variable, they don't depend. Then the sales are dependent, so our y. So x and y. So this is our x, and this is y. So we have 1, 2, 3. When you square it, it is 1, 4 up to 36. Then the sales 2.6, 2.62. When you square them, where are they? When you square them, supposed to get the figures there. Then you do x, y, you get the totals there. So here, he left one column, I don't know why. So in the total 4, so to find your b is sum of square xy over sum of square xx. So here you can use this to calculate the sum of square xy and use this to find the sum of square xx. This will be your homework because you use a lot of shortcuts, but I've explained how to find the variation in x and y. So the final answer is what? 0.054. Your b is, your a is simply summation of what? Y over n, which is the mean of y, minus b, summation of what? X over n, which is the mean of what? X. It's the same thing, don't get confused. This is that, and x bar is just that, and the b. So when you get your slope here, 0.05, you put it here. Then summation of x, summation of y over n. So our y is 17.37. How many are they? 1, 2, 3, 4, 5, 6. Over 6 minus the b we got here, 0.054. And total up on the y's, on the x, 21 over 6. Your intercept is 2.7. So we're going to put 2.7 minus 0.054x. So here, that is your regression equation. So suggest to him the rate at which the sales are rising. So these sales are rising at a rate of 0.054. Okay. Then they'll ask you now, use this equation to estimate the sales for the 7th week. So this is the number of weeks. Just put a 7 there. When you put there, you get your answer there and substitute. So this is how the regression is supposed to be done. So this is our regression tutorial. I hope it's been insightful. I wish you all the best. I will end here unless there are any burning questions.
Sorry, Coach, the 7 is the one which you are substituting in X. So that's 7 days in a week, right?
No, these are
okay. It's always been given 7th. Okay.
Yes, 7th week. So we are predicting. If they say the 8th, you put 8th week there. Leah, when you calculate this, let's memorize this answer here. What is the actual answer there? Just in case. The first one, that one was 0.237, remember? And here, Maggie, what are you finding?
I think it's 3.138.
3.138. Okay. Thank you so much. I'll end here.